Hello, my fellow YouTubers. This is Roy back again. This time I decided not to go live because of the issues I'm having with my somewhat magnets internet. So, I can see it's nice and clear, which is good. And you can probably hear me. So, watched that previous video I did and has a lot of parts that were missing. So I want you to notice that. See that wheel turning? That's because the magnets are stuck because of the north and south. And the object here is when these magnets are piled up here, and when one is approaching the other, they will mesh together. Well, so that's being restricted because of that. Interesting. There we go. So I got it out of the field now. Don't take much restriction when it comes to magnets. That's where I kind of come in and say, how much resistance you put in your coil would be similar to what resistance that this magnet has. For instance, so we have electrons moving through, traveling like a race car. The molecules, the atom molecules in this piece here are being shared and brought through the NASCAR racetrack, right? And there's a resistance that's built in by keeping this here, okay? That's the resistance I'm speaking about, that in magnetism, it's pretty similar than the resistance that you would have in using thin wire in this coil. You're building in that resistance. So that resistance, when you go to put power into this coil, the resistance that's built in this coil will be the residual resistance that's built into the magnetism of this coil. Hopefully that makes sense. But that seems to be the way this stuff works, by building in resistance into your electromagnet coil and the core, and then the reactance that happens with that determines how much induction the core, one by surface area, thickness, general surface area. The other is how much resistance you put in the coil or design the coil, is on how much inductance is going to occur of saturation of the energy into the iron, and the inductance that transposes back into the coil's magnetic field around it. Pretty cool stuff. So here we are. It says Ford Model A. You guys could see that? Ford Model A. I charged that up. It's got great resistance about it. So the pull force, it's called Gauss. And that Gauss, we're going to build a machine. Don't have it around here, but it's spring loaded. and we'll build a little round plastic gauge that will give us the pull strength of this magnet, and that resistance is built in this magnet. So the same resistance that's in this magnet, we're looking to take these magnets on the wheel and understand how much resistance that these have as a charged magnet, fully charged. How much resistance is in each one of these. So you got 5 times that resistance just built in, 5 layers of these magnets right here. And by the way, I have a good feeling that water in the center, while it's spinning, naturally we'll see the centrifugal force, we'll see build up, and the water start rising up the sidewalls. And if you had something curved to kick it back down, you would create a donut effect with the water. But what I'm more interested in with the water is that the high voltage charge that you could put in there would have a phenomenal type of experience coming out through the center clover ring and the ring below it right here, because these two here are oppositely charged. So not only do we have this spinning as an armature, but we also have in the internals is we have a negative is the clover isolated from the round ring underneath it, and that's a positively charged. And I have these outside wires going to be connected, one going to the positive charge, one going to the negative charge. The negative charge is also connected to the bottom plate. The bottom plate can be connected to your negative side of your power source, DC power source. Now on the positive side, you either have to treat this like a commutator, to where you would have some kind of brush type of connection, or you could use the chains he has with all that iron, tie that in to this negative side, which is connected to the battery and earth, and then you have the hook coming down. Well, actually, maybe all those chains and everything are hooked to the positive side. And then you have the hook coming down. And if you were to have something hanging off that hook that would make contact, you'd have a brushless contact that's not putting a drag on the system. Plus, the water, it has molecules in there that are explosive, especially the hydrogen side. So that explosive part of the water brings into the equation super energy. Bada bing, bada boom. So hopefully you guys have a better, clear vision of the start of this build here, that we're going to go ahead and we're going to figure out the resistance, because that's what's needed, and we'll be using the frequency, and we'll be looking into as Tesla would say, natural medium phenomenon, and then we'll be looking into the frequency of of the Schumann resonance, which Mr. Schumann would have calculated the lightning strikes that happen per second, divide them by 60, or times them by 60, and you would have that many pulses on this planet. That would be a frequency. But then on top of that, you also have a North Pole and South Pole on a sphere. Now, if this is the sphere right here, and you got a north and you got a south, you also have this high tension of sunlight that's streaming everywhere, okay? And when it's coming up to the planet, instead of it just coming up to it and bombarding it, it has electromagnetic field around it with two poles. So what's going to happen, there's going to be a compression on all sides from that energy. Now that compression, this is where flat Earth comes in. I'm not really a firm believer in the flat Earth because it doesn't make sense, but in this way of looking at things, it does make sense, where the compression of that energy flattens out that round sphere, but the decompression of the energy, which is the round ball that our Earth or any planet, the decompression of that energy is showing up its face in the atmosphere. And that atmosphere is something that's expanded and contracted by the force of energy that comes by the planet. So that donut type, you'll see when we make flat disk, for instance, this neodymium magnet right here. This is actually two of them, but it's real thin. So that means that the north side's here, south side's here. The thickness of that north and south pole right here on this round disk is enormous. The pressure is enormous because you're compressing north and south together. They don't want to go together. They don't want to go together. They want to be separate. But there is a separation, but they're compressed. So that compression would be the flat Earth. The strength of the material inside the magnet, which would be Earth, which would create the atmosphere around it because of your exhaust emissions from your material, which create this atmosphere. And then you have electromagnetic field that's able to expand. And the reason I'm talking about this expansion is because with turning the wheel, we are looking to look at these magnets in a way to where the field of the negative and positive is expanding out and comes back around, just like the ring you see right here. There's an expansion. Now, by compressing the expansion, you're creating the same thing you see in electrical circuits, which is the Lenz's law of if you were to take these magnets and you would put them up against these magnets, and you're creating a environment that has compression. And with that compression, you're seeing things like the wheel turning or the reaction between the two magnets. The thing that I want to focus on with this, and especially with you guys on showing you some of the stuff that I've realized by building this so many times, and then on